apologize. Technical difficulties. I just need to make sure that everybody can hear me. So what's going to happen is this is the abacus. When we look, this is the horizontal bar. This horizontal bar is what counts our beads. This is what counts our abacus. This is what counts the beads. So when I look at one, we have one. That's what one looks like. When I have two, we have two. That's what two is. Just like just like pencil crayons, right? We have two items. We have two things. We have two beads. That's all that means, right? So when we have three, one, two, three, we're looking at it. Oh yeah, you know what? We're looking at three. Oh, let me see if I can find three in my book. Right, three. We have three. I don't know what these are. I think these are like little chipmunks, right? So when we look at the three, we have one, two, three chipmunks. We have one, two, three beads on the abacus. When I do four, we have four koalas. One, two, three, four. We're going to have four on the abacus. One, two, three, four. I hope that makes sense. So then we have, let's see, we have five. There we go. Five horses. Five looks like this. One, two, three, four, five. That's what five looks like. When I look, let's go, Dolce. I need to practice. Oh, yeah, that'd be good. Let's see how far we can go. Let me just do a little review on how to read the abacus. And then we'll go into adding. So we have six. 1, 2, 3, 4, 5, 6. 5. So we're going to count from 5 and then we do 6. So we have 5, we have 6. So when we look, this will always be the value of 5 and then we add the 1 and then we have 6. So then what happens is we have 7. 5, 1, 2, 3, 4, 5, 6, 7. We have 5, 6, 7. 7 crocodiles, 7 on the abacus. And then we have 8. We have 8 little bunnies. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. So we have 8 bunnies. We have 8 on the abacus. I hope that makes sense. And then we do 9 little cows. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we look, we have 5, 6, 7, 8, 9. And that's how we count on the abacus. When we look, this is 9, 9, 9, 9, 9, 9, 9. That's what 9 looks like. So when we review, we do this. This is all ones. 1, 1, 1, 1, 1. And then when we do this, this is all twos. And then this is all threes. And this is all fours. When we look, we have 5. All of these beads are 5. And then we have 6. And then we have 7. And then we have 8. And we have 9. Hey, welcome back, Nom Nom. That's 9. That's what 9 looks like. Now, when we look, we want to make sure we understand how to read the abacus. So, what are we doing? We're doing here. So if I do this, this is 9. Why am I choosing here? Because I want to choose my indicator. I have this one or I have this one. So when you choose it, I want to choose this one as my ones indicator. So just like a Pokemon. I choose you. All right, I'll choose this one. So I have 9, and then what's after 9 is 10. Oh, wait, that looks very familiar, doesn't it? Because it looks like 1. That's 1. This is 1. It just depends on what column we're in. So, Dolce, we're going to go some. Looking for my. There we go. Okay, we're almost there. We're almost there. Because we're going to go straight into adding and subtracting. And I'm frozen. All right, I'm back. I think I'm back. So when we look, we have our ones, our tens, our hundreds, our thousands, our 10,000. So I chose this one to be my ones. And then after ones, there's a decimal. There's a decimal that sits right here. So there's a ones and the tenths and then the hundreds. Thank you, user. Welcome back. I believe it's user welcome back. 869. 869. And then blah, 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 blah. All right. So Dolce, what kind of what kind of adding and subtracting are we doing? Do we have any specific questions or what are we doing? So when we look, while you guys think of a question, I will continue to count. So this is 10. Then now we can count by tens. 10, 20, 30, 40, 50. This will be 50. So if I did this, this is 55. If I did this, this is 555. 55 plus 55. Okay, let's do it. Let's do it. 5 plus 5. All right, fine. All right. So when we look, the question is, what is the question? Oh, I gotta move my stuff. Let me move my stuff. All right, there we go. Thank you for the question, Num Num. So when we look, we have 5 plus 5, and then we're going to add it. So the first thing we're going to do is we're going to put 5 on our abacus, right? 55 on the abacus. That's what 55 looks like. When we add 55, what are we going to do? What are we going to do? We are going to do the first thing is we're going to add 5 to over here. Can we add the 5? Can we add the 5? No, we cannot add the 5. How do we add the 5? Do we remember how to add the 5? The problem is what? When we look, is there enough beads to add the 5? No, there's not enough beads to add the 5. Can I add a 5 to? No, I can't, right? There's not enough beads to add the 5. What do? I need to use this. I need to understand plus the 5 is equal to plus the 10 minus the 5. So I'm going to plus the 10 minus the 5, plus the 10 minus the 5. I'm going to rewrite it. I'm going to say plus 5 is equal to plus the 10 minus 5. That's what I have. So what I'm going to do is I'm going to plus the 10, 1, 0, 1, 0. And then I need to minus the 5. And now I'm here. I need to plus the 5 again. What do? I do the same. Plus the 5 equals to plus the 10 minus the 5. Plus the 10 minus the 5. Plus the 10, 1, and 0, and then minus the 5. So my final answer is 110. That's a good question, Nom Nom. So 110. Oh, sorry, 110. That's what it is. All right, Dolce, do you have a specific? Hey, Cameron, welcome back. I'm surprised. There's not too many people that come back. Oh, this is my favorite. Oh, green crayon. I'm so happy. I'm so happy you're back. Welcome back. Right. So let me know another question, or am I just going to go through? I'm going to go through some. Dolce, are you talking about adding the 5 or adding the 10? So what we did is we add the 10. We can do more. We can do hello Neon. Yes, Compu Bear, I'm back. Was it a vacation? I don't know. It was a vacation. I think vampire, vapor vampire. Please do the basic one so I can see how the abacus works. Oh, that's a good idea. Thank you for commenting. What's an abacus? This is an abacus. This is a counting tool. Yes, I love the abacus. Thank you so much, Aura. So, vapor, let's do it. Let's do some review. We're going to review what a 0 is. This is what a 0. A 0 means that none of the beads are touching the horizontal bar. Thank you so much for commenting. I appreciate that because I don't know who's in this room. Okay, so Cameron, if you have any questions, let me know as well. All right, so that is 1. Oh, no, sorry, that's 0. So then we do 1. We have 1. When we look, there's this 1 bead touching the beam. When we do this, this is all 1. 1, 1, 1, 1, 1, 1, 1. Then we want to do 2. If I want to do 2, I do this. This is 2. These are all 2s. 2, 2, 2, 2, 2, 2, 2. And then we have 3. All these beads, when they go up like this, these are all 3s. 3, 3, 3, 3, 3, 3, 3. And then 4. What's 4? Same thing, right? 1, 2. I'm sorry. 4, 4, 4, 4, 4, 4, 4. Right? 5. The top bead touches the horizontal bar. 5, 5, 5, 5, 5, 5, 5. And then 6. What? Well, look. Uh, if I did this, 1, and then I add the 5 like this. If I add the 5, now I have 6. Oh, good, Pin. Thank you, Pin. We're putting a pin on it. All right. So then we have 6. And after 6, we have 7. These are all sevens. 7, 7, 7, 7, 7, 7, 7. Cool? Make sense? And then 8. Easy. 8, 8, 8, 8, 8, 8, 8, 8, 8. And then 9. 9, 9, 9, 9, 9, 9, 9, 9. Is there such a thing as an abacus, but it lets you use a higher denomination? What sort of denomination are we talking about? I am not sure. So when we look, if I do this, this is 1, 2, 3, 4. After 4, we have 5. So if you notice, I'm looking at one column. When I look at one column, I can now start using place values. Hey, Bri, welcome back. So what we're doing is when we look at the place values, this is the place value. We have our ones, our tens, our hundreds, our thousands, and our 10,000s. So when we look, we have 5, 6, 7, 8, 9. After 9, we have 10. 10 is 0 and 1. When we have 0 and 1, 0 and 1, just as how we write, just as how we write 0, 1. And then we have 11. 11 is 1 and 1. Every column is a place value. Every place value has a digit. So when I have 2, right, 12, it's a 1 and a 2. That's what 12 looks like. When we're talking about it, and I want to add the 5, now I have 17. Thank you so much for the heart me, CompuBear. So does that, I'm not sure, Pin, if that's what you mean by higher denomination. I hope you guys can hear me. Okay, good. So how are we doing? I think they meant a higher base number. A higher base number. I wonder. So when we have a 7, this is 7 digits. You can go higher with the 13 column. Is that what you mean by more digits? Vampire. Vapor. When we look, the question is 3. When I add the 3, my next question is do I have enough? Can I add a 5? Yes, we can. So there is no formulas involved. So the first thing we need to understand is how to move the beads. So right now we have 8. So it's easy to see that we add the 5, we add the 3, that makes 8. When we have 4, and I want to add the 5, that makes 9. If I have 7 and I take away 6, we will know that we're going to take away the 6 minus the 5 minus the 1. So when we are looking at it, now we're going into simple adding and subtracting. And it all goes back to the added. So in abacus world, what we're going to do is we're going to focus on the added. When we look at it, we want to focus on the added. We do not want to focus on the result. Thank you, Vapor. So what we want to do is we're going to add the 7. When we add the 7, my question is hello, Char, can I add the 1? Yes, we can. So we're going to add the 1. Is there enough beads to add the 1? Yes, there is. So we're going to add the 1. So remember, we're going to focus on the add-in. We're not going to focus on the result. So when we look, here is 5. When I have my 5 and I add 2, can I add 2? Right? So we can add the 2. I just need to move these 2 beads that I added 2. My final answer is 7. Again, this is simple, right? Simple means that we have enough beads. So in this book is what I'm doing. In this book, we do what we call simple adding and subtracting. We do simple adding and subtracting. And then we have 3. Is that 3? Yes, same thing. I have 3 on the abacus. And I'm sorry, I have 5 on the abacus. And then I add the 3. Is there enough to add the 3? Yes, there is. I can't wait to get paid to get the books. Oh, hey, that's great. So now with this specific book, I have like other activities. This is a cutting activity where they cut the puzzle and then they answer the number and then they find the answer on the puzzle piece. So when we look, we have four. Four doesn't have a lot of addition questions. Why? Because it's always this whole thing. So either you have a 0 plus 4, which is this, and my answer is 4, or 5, and then you add the 4, and my final answer is 9. I'm hoping that I take my little breaks between my lags. All right. So if you know how to add, you will know how to subtract. Again, we're focusing on the add-in. Not an add-in now. It's called a subtract head, which is dumb, but whatever. It's a subtract head. So if I have 3, I add the 3. I want to take away the 1. If I take away the 1, my final answer is 2. TikTok. Keisha. So when we look, we add to the horizontal bar means we go up to the horizontal bar. We go up or down to the horizontal bar. When we touch the horizontal bar, we're adding to it. When we are subtracting, we move it away from the horizontal bar. I hope that makes sense. So when I have 3 and I want to take away the 1, I just move it away. So now what we're doing is we're subtracting. Hey, Laura, welcome back. Welcome back. Oh, good. You did get your email. Yes, great. I'm so happy. Yeah, it took a little bit to find it because I have a lot of worksheets. So what's going to happen is if I have 7, my question starts with 7. I'm going to have 7. I want to subtract the 1. When I subtract the 1, I'm moving it away from the horizontal bar. Yeah, not a problem. You're welcome, Laura. So here we have 2 minus the 2. My question starts with 3, and I want to subtract the 2. When I subtract the 2, I'm taking it away from the horizontal bar. I just do that. That's what I'm doing. I'm minusing. I'm subtracting 2. So my final answer is 1. What's going to happen? Wait, what's going to happen? We're just going through and understanding how to move the beads. So the first thing we do is we're understanding how the beads are moving. So when I have 4, I'm adding to the horizontal bar. Now what I'm doing is I'm going to subtract the 3. That's the Hey, and welcome back. So when minus a 3, I have 1. We're moving it away from the horizontal bar. So let's see how fast we can do this. So now we have 4. Again, if I have 9 and I want to take away 4, all I got to do is away from the horizontal bar. And my final answer is 5. Now we know how to add, right? We know how to add. If I want to have a 5, let's start with 3, which we did before. I have 3. I have 3, and then I want to add the 5. I'm going to add the 5. Can we do it? Yes, we can. And we have our final answer is 8. And then we have 6. Again, 6 is, if I have that, 6 looks like this. But when we're adding it to something, right? We have 2 or 3. We have 3, 1, 2, 3, and we add 6. That's what it looks like, adding 6. My final answer is 9. So then we have 7. Again, we have 1 and then 7. 5, 6, 5, 6, 7. And we bring it together like that. 7. So my final answer is 8. 5, 6, 7, 8. Anybody have any questions? So what we're doing is we're, again, just looking at how to move the beads. And, so that's one of the things is if this is my answer and I do this, don't flick too hard. Don't flick too hard because the beads on the abacus is very easy to move. Even if you bump it, then your abacus will have the wrong answer. So you want to make sure you use your left hand to stabilize the abacus. So when we look, we want to make sure that we have it solid. So these are very easy to move. And it is also a standard size. No matter how big and fat and burly your fingers are, we're being gentle and only move the edges of the beads. right? So no matter how big, even like Bigfoot with big hands should be able to use the abacus because they're doing this, right? All they would be doing is this. So if I want to do two, I'd be one, two, three, four, and then five, six, seven, eight, nine. Oh, thank you, CompuBear, for the love. Oh, thank you so much. So, Keisha, how are we doing? I don't know if you're still around. So that's what adding on the abacus is. Again, when we add, we could do subtract. So we have our 8 and then we have 9. 9 is not a very difficult number because it's just like that. That's all 9. And then we have to do the minus, right? Minus 7. So when we look, adding the 5 and take away the 5. If I have 9 and I want to minus the 5, I'm just removing it away from the horizontal bar. This is 4. So if I look and I have 6, right? Minus 6, this is 7. If I have 7 and I want to take away 6, oh, Keisha, Keisha. Good. Any question? So we took away the 6, we have 1. How does that work? We're all right? And then we have 7. If we have 8 on the abacus, we have 8 on the abacus, and we want to take away the 7 is 5, 6, 7, and we take it away like that. So my final answer is 1. How are we doing? Any questions? So far, so good? So we have 8. So my question is 8. So I have 9, and I take away the 8. When I take away the 8, all I'm doing is moving the 8, just like that. How are we doing? Okay. Excuse me. So we can continue on with adding and subtracting. How are we doing? We're all right? That was this book. What's the next book? The next book is CompuBear. Good, 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 good. We're gonna do this one. We're gonna do this one. All right. What does that mean? Well, it's what happens when we don't have enough beads. Oh, excuse me. Ah, I want to learn this. It's so interesting. Oh, Modsy, do you understand how to read the abacus? Or when did you join? Did you join like after reading the abacus, or do you need to know how to read the abacus? Because it doesn't help if you don't know how to read the abacus. You know what I mean? It'd be good if you know how to read the abacus. All right. Can you read the abacus? That's the question. Oh, I need you to. Okay, so let's do a little review for Matsi. That's the wrong paper. CompuBear. Do you know CompuBear? Do you know where that movie came from? Where the little sound bit came from? I don't know if you're as old as I am. I don't know who as old as I am. Laura, do you know what movie that came from? All right, so we have 0. This is 0. When the beads are not touching the horizontal bar, this is 0. When we have 1, only need to use the 1 bead. After 1 is 2. After 2, right, is 3. 1, 2, 3. I'm a big Arnold Schwarzenegger fan, and he made this one movie called Total Recall. And it was when the alien was in the stomach of the guy. I forgot his name. I forgot the alien name. But that's when it was. I forget if Colin Farrell, right? Oh yeah. Uh, See, only old people know this. That's how you know we're old. Yeah, that's what it was. Quato. Yes, that's what it was. Quato. Okay, so this is 3. 1, 2, 3, and then 4. We're at 4, right? Makes sense? This is 4. Now what's going to happen is we have 5. 5 looks like this. 5 is always going to be the top bead. The top bead will always be the value of 5. So then we can look. If we do 1, right? This is 1, and then we add the 5, now we have 6. If I have 2 and I want to add the 5, now I have 7. I have 3, I add the 5, now I have 8. I have 4 and I add the 5, now I have 9. Does that make sense? So when we look at it, we're going to talk about every column, excuse me, every column has a place value. The place values, ones, tens, zeros, I'm sorry, ones, tens, hundreds, thousands, 10,000. You might be wondering why I'm over here. The reason why is I have this label. This is my label. This is my ones label. I can read your mind. So I have this label right here. This is my dot. It's just my ones indicator. So you could choose this one, or you could choose this one. If I choose this one, you'll notice that my ones will be here. I do the ones and tens, but notice I don't have any more beads for the hundreds. I have no more columns for the hundreds. That's why I want to go back to, I want to choose this one. So when I look, I have my ones, my tens, my hundreds, my thousands, my 10,000. My decimal sits between my ones and my tenths. And then I have my decimals, my tenths, and then my hundreds. So when I look, um, I'm trying to find paper. Oh, here it is. Sorry. Okay. So I did a post on this. So if I was to do decimals, right? If I was to do decimals, it would look like this. We have 1.01. Okay. If I did this number, it'd be 123.62. And then what happens? Well, if I do my next one, I have 44.30. Does that make sense? So we can do decimals here. There's no advance. Whew, okay. Yeah, that was the one thing I didn't. Yeah, so I did that as a post. What else? What else did I do? I did a few posts today. I don't know. It was just like, anyways. So what did we do? Well, okay, so now what we're gonna do is we talked about how to add. So that's where Motzi came in. We were adding. We were doing simple adding, and then now what we're gonna do is we're gonna do what happens when we don't have enough beads. Is that all right? So when we look, if we don't have enough beads, that's what we do, right? Oh, good. That's what we're going to do. I have a question for you guys. Why are we teaching children plus the 1 and 4? 4 plus 1 is equal to 5, and 1 plus 1 plus 4 is equal to 5. Why are we teaching this to children? Why are we teaching the children how to make a 5? That's a question. It's not a rhetorical question. Like, I really want to know. Is there a specific reason why we're doing this? 3 plus 2 is equal to 5, and 2 plus 3 is equal to 5. This one here is what we call commutative property. But we don't do it in the actual sense of commutative property. The reason why is because we always focus on the second add-in. This is what makes the difference. But we kind of do it. Anyways, why do we teach the children how to make a 5? That's a question. I don't know. I know why I do it for Abacus World, but in mainstream, why do we teach the children how to make a 5? I don't know. Yeah, I don't know, right? Like one person said it was because it's a half of 10. And I'm like, all right, I don't know. And then we're like, okay, well, we have 5 fingers. Okay. We could do it because we have five fingers on our hand. We could do that. Okay, but anyways, I'm going to show you why we do it in the abacus world. Why are we going to do it in the abacus world? Because if I have my question, when I have my question, here's my question. 3. I'll do 3. 3. Now remember, we're teaching children this, right? We're big people. We already know what 3 plus 4 is. But I want to show you what it's like to show you the fundamentals. So that's what I'm doing. I'm showing you the fundamentals, and the questions are easy, right? So we're not going to memorize. What we're going to do is we're going to understand and logically think. This is my question. 3. I want to add the 4. I notice I don't have enough beads to add the 4. I know this concept. Plus the 4 is equal to plus the 5 minus the 1. I'm sorry, plus the 5. I know to make a 5, 1 plus 4 is equal to 5. What we're going to do is we're going to isolate the variable. We're going to have 4 is by itself equals to 5, but 5 is too big. 5 is too much, so we need to minus the 1. When we minus the 1, then we have this. This is what we call a formula in abacus world. Why? Because now we can utilize this 5. So if I add the 5, that's too much. I need to take away the 1. So my final answer is 7. Okay, let me do that again. Let me do that again. That looks confusing. All right, that's okay. So let me do 3 pennies. If I don't know what part of the world you are. However, in America, we have these 1 cent. 1 cent. Welcome to the I'm so happy you got it. Okay, good. But I'm going to continue on with my thought. So I have 3 cents, and I want to give you 4 pennies. I want to give you 4 pennies. Hey, Jay, I want to give you 4 pennies, but to give you 4 pennies, I only have a nickel. This nickel is worth 5 cents. So if I give you this nickel, I've given you too much. So I need the change back. So I'm going to give you the 5, and I'm going to give my change back. So you'll be left with 7, and I have my 1 penny back. So I add the 5, which is my 5 pennies, my nickel, and then I take away the 1. So my final answer is 7. We can do it again with 4, right? 4 plus 4. We're not going to memorize. What we're going to do is we're going to understand to utilize our formula. Plus the 4 is equal to plus the 5 minus the 1. So what does that mean? Well, I want to have my 4. I have my 4, 1, 2, 3, 4, but I only have a nickel. I want to give you, I mean, it's more than enough, right? It's more than enough. If I give you this nickel, right, this 5 cents, it should be enough. But I've given you too much. You need to give me back 1 penny. So my final answer is 8. So let's do it again. Plus the 5 minus the 2, and my final answer is 8. Does that make sense? Yeah? So, right? Welcome. So great, great. So we can do it again with the 3s. So if you notice, 3 has also the same property. You sold me. So 3 plus 2 is equal to 5. What? 3 plus 2 is equal to 5. Remember, this is what we teach the kids, right? But what we're going to do is we're going to power up our equation. We're going to power up our, oh, thank you so much for the heart me. We're going to power up our equation. We're going to power up our addition sentence. So it's 3 is equal to 5 minus 2. So when we look, my question, I have 4. When I have 4, like, why? You can't see it. When I have 4, that's my question. I have 4, right? 1, 2, 3, 4. I have 4. Then what do we do? Well, it's worth 3 cents, but I only have a nickel. Remember, we can power it up. Plus the 5 minus the 2. Plus the 5 minus the 2. I'm going to give you my 5 nickels, my 5 pennies, right? My 5 cents. I'm going to give you my 5 cents, but that's too much. So I take 2 away. So my final answer is 7. That's what we're doing. All we're doing is math. Thank you for joining. Thank you for joining. We are talking about math, arithmetic, basic arithmetic. We're talking about adding, subtracting, multiplication, division. But notice what we needed to do is we need to understand how to subtract and how to add. Because we know how to subtract, we know how to add. Ah, thank you, Laura, for the heart puff and the heart me. Thank you so much. Does that make sense? When are you going to do some adding? Come on, Ethan. You're so funny. You're so funny. It all depends on how many people we can get across. I think the biggest, my phone is dying, but I'll definitely be back. Okay, Matzi, cool. So we can do it again. We can do the 3. 3 plus 3. 3 plus 3. We want to add another 3. To add another 3, what are we going to do? Plus the 5 minus the 2. What are we going to do? Plus the 5 minus the 2. And my final answer is 6. How are we doing? Dolce, are you still around? What's going on? You've been very, 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 very quiet. Very, very quiet. How are we doing? We all right? What's going on? Okay, you know what? Let's do some. Oh, what's this? What are we doing? I want to do this one. Okay, good. So let's do minus. I'm doing my good, good, good. So let's do the new book that I got. I got a new book. I just finished it. It's this one. Minus the 5. Minus the 5. Minus the 5. We're going to go subtracting now. So remember, we're going to review. We review that 1 and 4 is a pair. So as we go through, here it is. Minus 4 minus 1 equals to minus 5. Why are we going to do that? Because here is my question. 8 minus 4. Do I have enough beads to minus the 4? No, I do not have enough beads to minus the 4. So what am I going to do? To minus the 4, what do I do? Oh, where am I? There we are. So we're going to minus the 5 plus the 1. We're going to minus the 5 plus the 1. And my final answer is 4. So what are we doing? We are now subtracting. Minus the 4 equals to minus the 5 plus the 1. That's what we're doing. When we look, we can do it again. So here is the question. 16. So show me 16 on your abacus. 1 and 6. When I do that and I minus the 4, can I take away the 4? In this column, can I take away the 4? No, I can't. So how do I minus the 4? Minus the 4 is what? Minus the 5 plus the 1. So I want to minus the 5 and I add the 1. My final answer is, what's my final answer? Please let me know. I did it. Oh, good. Compute Bear. Good job. 12. Thank you, Laura. Thank you, Compute Bear. Thank you, Ethan. Yes, 12. So we can do it again. We can do 17. If we do 17, oh no, let's do 18. 18? Let's do 8. No, we already did 8. Let's do 6. Let's do 6. Can we do 6? If I do 6 and I take away the 4, right? Take away the 4. I'm going to minus the 5 plus the 2. And my final answer is 2. All right, so that is minus the 4. Yay! Here is minus 3. When we take away the 3, we want to use this as a review. Minus 3 minus 2 equals minus 5. So then what do? We need to move the beads up. We want to minus the 5 plus the 2. Here's my question, 7. When I have 7 and I want to minus the 3, here is the formula. Here is what I'm going to substitute. I'm going to minus the 5 plus the 2. I'm going to minus the 5 plus the 2. My final answer is 4. What did I just do? There's 7. 7 is right here. I need to take away the 3. To take away the 3, I think I just said those wrong. Sorry. So what's going to happen is minus the 3, minus the 5 plus the 2. My final answer is 4. Christina never used an abacus. I'm so confused on how to use it. Let's do a little review for Christina. Christina, are you still around? Hey, heart. Okay, good. So this is 4. Anytime the beads, 1, 2, 3, 4. Anytime the beads are touching this horizontal bar, anytime the beads are touching the horizontal bar, this is what's being counted. So I have 1, 2, 3, 4. When I look, this is 1, right? When I have that, that's 2. Touching the horizontal bar. They're all holding hands and singing kumbaya. Oh my God, I use the word kumbaya and the kids don't know what that is. And I'm like, whoa, I'm old. Okay, 2, 3, and then 4. After 4, we have 5. The top bead is a value of 5. So we have 6, 7, 8, and then 9. People don't know kumbaya. Yeah, they don't know what kumbaya is. And I'm like, kumbaya. And I was like singing it out too, right? So this is 9. If we look, this is 10. How do I know this is 10? Just as how we write it, 0 and 1, 0 and 1. Why? Because every column is a place value. Every place value has a digit, and it only goes up to 9. So we have 1 or 10, right? 20, 30, 40. 40. 1, 2, 3, 4, 40. And then 50. 50, 60, 70, 80, 90. Hopefully you got that. Hopefully I took a little break, right? So we have 90. What's 10? 10 looks like this. 10, okay, Laura, see you later. 10 is not this. 10 is 55. So then this is 55, this is 65, 75, 85, 95, and then we have 105. This is 100. Why? Because we have our hundreds, tens, and ones. This is 1,000. If you notice, there's these dots. These are groupings. I choose this one to be my ones. I choose this one to be the thousands. So if you look, if I choose this one to be my ones, just like a Pokemon, then I have ones, tens, hundred, thousands, 10,000. However, if I chose this one, then I only have ones and tens. And I don't have any more room for 100s. When we look, we want to be able to make sure that we have enough columns for the digits we have. So that's why I use this one. When we look, let's say I have my question is 555, 5555, and I do this, do not flick too hard or your answer will become wrong. Like Zeus. Do not flick too hard. You want to be gentle and you want to be happy when you do abacus. And then when you look, you're going to move the beads with your the edges of the beads. So this is 2, this is 4, right? 1, 2, 3, 4. Notice that if my hands were big and burly and pudgy, you should still be able to move the beads because the way the beads are shaped. Does that make sense? We don't want to be aggressive to move the beads. Don't be aggressive. Just be gentle. Be gentle and happy. Be gentle and happy. Okay. So that was moving the bead. Oh, make sure that when you hold the abacus, hold it with your left hand and stabilize it. Well, how am I supposed to hold it? What? Oh, like this. How does it work? Oh, what? Is that how you're supposed to hold it? Yeah, you hold it with your left hand like this. And you just hold it. And it goes down like that. You can't do it like this because of gravity, right? Then all the beads come down. Well, it's supposed to come down. So it's not supposed to be like this. And it's not supposed to be like this. I'm just showing you that there are the beads, right? I'm just showing you how to move the beads, right? We're not moving the beads like this. It's not going to be horizontal. Because if it's horizontal, then I don't know how you're going to get the place value. right? We don't read our numbers like this. We read our numbers like this. So, okay, I'm just looking. Curious. Is there a left-handed? You know what? There is. No, there is not a left-handed abacus because what's going to happen is even though they have their left hand, they'll keep their pen on their left hand, and they still hold it with their left hand. They still need to hold the abacus with their left hand, and they do the abacus with the right. Right? They do calculations with their right, and then they write with their left hand because your brain goes left brain still does the arithmetic, the right brain does the drawing. I love this. I've been watching a few days. Oh, so oh, fantastic, fantastic. So let's do a little review for Chris. Chris, are you still around? Because if not, then I'm going to continue on. I don't know if Chris is still here. Oh, good. So let's do a review. We're going to count on the abacus. 1, 2, 3, 4, and then 5. This is 5. No matter what, that's 5. 5, 5, 5, 5, 5. These are all 5. So if I did this, that's all 5. Then when we do 6, that looks like 6. That's 6. 6, 6, 6, 6, 6, 6, 6. And then 7. How do I know? 7, 7, 7. Each column is a. Okay, am I back? So this is 7. 8 just looks like that. That's what 8 looks like. And then 9 is like that. Those are all 9s. That was a wild glitch. Yeah. Could I use an abacus if it was attached to my hip? I LARP merchant, and I've been thinking to have it. I'm thinking right now. You could use the abacus. You could use it, like, but you would have to like hold it, right, and make sure you're stable. But yeah, you could, and as long as you're not going to use it to count anything, if that makes sense, Foxy. You know what I mean? Like it doesn't keep your tallies if that's what you're looking for. If that makes sense, you would have to bring it out and you would have to like clear it, and then you can use it. You could. Um, I don't know. Maybe you should. Maybe I would recommend something a little bit bigger, which would be the Chinese abacus. This is a Chinese abacus. It's a little bit bigger and it might be a little bit better as a prop, if that makes sense. The reason why, it would still be the same thing, but the beads are not as easy to move. Um, yeah. So maybe we do the Chinese one, right? Maybe the Chinese one would be better, if that makes sense, Foxy. I mean, that's a really good question. But I don't. I think this is too small for it to be part of a costume because you kind of wanted to. I mean, unless you get this one, but then I don't know, it's a little small for a costume, if that makes sense. I don't know if you're still around, but that's what my thought. My thought would be a nice big one, right? You can even use the 10 column one. That would be even better, um, as a prop. If it's to like really do arithmetic, I wouldn't use it. I would modify it. I would do, you know what I mean? Yeah. So I would get a bigger one because then people can see it because this is really small. See, that's my hand, if that makes sense. This one is like as big as my face, right? You could This is a teacher's abacus, and this is way too big. And it's heavy. You know what I mean? So I think the Chinese one or the 10 bead one is a good size for your costume. That's a great question though. Thank you so much. That's a really good question. I mean, but yeah, that's my personal thought. Cool. All right, where are we? Am I a teacher beyond the abacus? No, I'm not. I'm just an abacus teacher. I do not teach in the schools. I'm hoping to bring this to schools, but we'll see. We'll see if it gets there. All right. So, no, you know what? let's go back. This one is not complicated. It works very similar to the Japanese abacus. This is a Chinese abacus. And so when we count it, it's the same thing. 1, 2, 3, 4, 5, and then 6, and then 7. I'm sorry, 5. 5. Because we have this, we want to trade it in. That would be 5. So 5, 6, 7, 8, 9, 10. Because we have 10, this is a 5. We can trade it in for the top bead. The top bead is always going to be 5. So this is 10. We're going to trade this in and we're going to do that. So now we have 10. So we have 10, 11, 12, 13, 14, 15. Trade this in to do that. That's it. Okay, I hope the schools use it too. Yeah, that's the hope. The Chinese one, as I was curious with, but the extra beads. The extra beads, if you want to, you don't need to buy the Japanese one. You could use just the middle part of the abacus. You know what? If you have the Chinese one, it's really simple to do 6 times table, which is really fantastic. Because if you look, 6 times 1 is 6. All I got to do is bring in the 2 beads, right? We know how to make a 6, right? And then 6 times 2 is 12. How do I know? 1, this is 10, and this is 2. And then trade this in, and we go with that. That's 12. And then 6 times 3, do it again. It's 18. 1 and 8. 5, 6, 7, 8. And then we do it again. 6 times 4 is 24. 20. There's a 10 here, so we're going to move it over here. So we have 24. And then we do 6 times, what do we do? 6 times 5 is 30. How crazy is that? 5, so I'm going to trade this into 5. Then I'm going to trade this in for a 10. Yeah. Isn't that cool? Yeah. That's so cool. I was like looking at it. I was like, oh, I've always wanted to learn because they didn't teach us in school anymore. Yeah, I don't think they've ever taught you. You would have to be in a very special school to learn this. Wow, that's very simplified. Yeah, right. I was so when I read that, I was like, oh my god. And then 6 times 6, right? 6 times 6 is 36. It doesn't work for everything else. It only works for the sixes. It only works for the sixes. You could do it for the 5. You could do it for the 5. 5. 5 times 1 is 5. 5 times 2, 5 times 3. So you trade this in, right? That's 3. 5 times 4, trade this into this, and then trade this into this. You could do it 5. Yep. 5 times 5, 5 times 6, 5 times 7. So trade this in, 5 times 7. 5 times 8. So then this is, oh yeah, you could do it by 5s. Ha, hi, Carter. I'm just looking at it. It's really interesting. I mean, every abacus has its pros and its cons. So I haven't tried the 4s. No, 4s you need formulas because you need to add a 4. To add a 4, it's plus the 5 minus the 1. Yeah, you can't do it with the 4s. You can only do it with the 5s and the 6s. Oh, that's interesting. All right. Whew. Okay. Dubs. Carter. Welcome back, Carter. Okay, let's do a review. We're going to count 1, 2, 3, 4. That's 4. That's it. That's it. We're done. 4. The top bead is 5. If I do this, this is all 5. 5, 5, 5, 5, 5, 5. And then this is 6. We have 7s. We have 8. And then 9. All of these are 9s. Does that make sense, Carter? How you doing? Okay, wait. Christina, I thought the top was 10. The top is 10. Oh, la, 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 la. I'm sorry, I'm reading all the comments. Okay, so why does the Chinese alphabet start with the one on the right and the Chinese and the start with the one on the decimal? Oh, it's not because of that. It's because the Chinese one doesn't have a ones indicator, so you can actually choose whatever ones. But the problem is if I walk away, if I'm doing calculations and I forget where my ones is, then I have a problem. Whereas the Japanese made it conscious effort to label their columns. That's all it is. I meant coming in and seeing you to do multiplication. Could you explain from the beginning, Preston? So when we count it, we have 1, we have 2, we have 2. As long as you So when we do 2, we have 3, 4, and then 5. So if I did this, this is all 5. Because the beads are touching the horizontal bar. Because the beads are touching the horizontal bar, we have counted, these are all 5s. Then we have 6, and then we have 7. These are all 7s. And then this is all 8s. And then this is all 9s. But then what happens if we want to count it? So we count from 9. After 9 is 1, 10. I'm sorry, 10. How do I know? Because as Chris mentioned, we have an indicator. We have a ones indicator. That ones indicator is used by the dot. This dot right here lets me know that this is my ones. So when I look, this is 0 and 1. Just as how we write our 10. 1, 0. That's how you write the 10. Just as how we read 1, 0. 11 looks like this 1 and 1. After that, 12, 1 and 2. Make sense? So, cool. I don't mind the lag because it gives me time to breathe. Okay, nom nom. Can we do 8 plus 4? We can. We can. That's a very good question. So when we do 8 plus 4, we're going to have to remember what? We're going to have to remember how to make a 5. 8 plus 4. So let's start with our question. 8. So I do 8 plus 4. Now I have 8 on my abacus. I have 8 on my abacus. My question is do I have enough beads to add the 4? No, I don't have enough beads to add the 4. What do I do? Can I add the 5? No, I can't. Why? Because I already added the 5. So my final answer is this. Plus the 10 minus the 6. Thank you, Num Num. Yes. Plus the 10 minus the 6. So my final question is 12. My final answer is 12. Did that make sense? But the biggest thing is to go through the framework, the abacus framework. As we go through the abacus framework, it's a process. Oh, good, Preston. I was just about to ask you if that made sense. So this is how to make a 10. But in here, what we're doing is it's called grouping, regrouping, and what else? Trading, carrying on, all that stuff. That's what we're doing right here, right? This one here is more like trading. But we're making a 5. And to make the 5, right, we have our question 4. If my question is 4 plus 4, is there enough beads to add the 4? No, there's not enough beads to add the 4 because I already have a 4 here. Then the next question is, do I have enough to add the... Okay, I think I'm back. All right, so the question is can I use the 5? Yes, I can. So here it says, it gives me the directions, plus the 5 minus the 1. So I'm going to plus the 5 and I take away the 1. My final answer is 8. The question was 4 plus 4, right? Make sense? Cool. Creative wrinkles. That's a funny username. All right. How are we doing? We're okay? So when we look, we are adding, and then we could do the same thing with subtraction. Subtraction. Oh, here we are. So when we look, we have 7. We have 3. To minus the 3, we're going to minus the 5 plus the 2. So when we look, we have 7. When we have 7 on my abacus, and then I do the 3. Notice I'm going to substitute minus the 5 plus the 2. I'm going to substitute it. Associative property. I'm trying to figure out how to do associate. Oh, you know what? Associative property will happen when we do the two-step. I think I figured that part out. So what we're going to do is we're going to minus the 5 plus the 2, right? Minus the 5 plus the 2. My final answer is 4, right? How did I do that? Well, if you notice, this is making the 5. When we know how to make a 5, right? We're teaching the kids how to make a 5. And we're not memorizing doubles. We're not memorizing doubles. What we're going to do is we're going to power up our equations. We're going to power up our math concept because the math concept we have is what we're teaching. 3 and minus 2 is equal to minus 5. When we power it up, we're actually making it and we're utilizing it. We're making it better. We're making it stronger. We're making it different. You remind me of my teacher in my AP statistics. Oh, hey, welcome back. Right. That's what we do. We modified our equation. So when we look, right, it's 7. We go back to 7. That's 7. And if we don't have enough to add minus the 3, when we minus the 3, all we got to do is minus the 5 plus the 2. Minus the 5 plus the 2. My final answer is 4. All right. So we can do it again with the 2. What are we going to do? We're going to do 2. Right? Same thing. See, it's very similar. It's very similar, but the concept gets repeated. The concept is the same. It just gets practiced and practiced and practiced. And as we practice, it will become easier for you to see what we're trying to do. So if we have 6, my question is 6, right? My subtract head is 5. When I minus the 2, I want to minus the 2. To minus the 2, what do? I need to So it's just taking away the 5 and then adding the 5. It is. But notice it's too much. If I take away the 5, that's too much. So I need to add the 3 to balance the equation. So my final answer is 4. Does that make sense? I need to balance the equation. I use the 5, right? I use the 5, but I need to balance the equation. To balance the equation, I will take away the lower beads. Yes, Preston. Yes. Exactly. So I take away the 5 and I add the 3 because I want to balance the equation. It's all about being balanced. It's like taking the whole and adding the 3. Yes, the 3 separate ones. Right. So what we're doing is we're breaking apart, breaking apart the 5, but you can't break this apart, right? So that's why we have to utilize the bottom beats to help us break it apart, which is interesting concept. Um, because it's kind of like in mainstream math about adding in 10. Oh my God, that's right. It's like adding the 10, right? You got to break the 10 apart in order to use it. We're doing it in a smaller, what do you call it? We're doing it earlier in the abacus world. Because remember when we have 20, right? We have 2 10s. Because we have 2 10s and I want to take away 4, right? What do we have to do? We have to trade this in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I take this away. And then what do? Take away 4. So I take away 4. Right? I'm asking her if we can do division. We can do division. But I think that would, yeah, I was going to ask the same. You can do division on the abacus. It is very much possible to do division on the abacus. But I don't know if we are ready to do it right now. But I don't know if I have a post on division. I might have a couple of posts on division. Math. Elias. Yes. AKA Elias. Yes. So that's the interesting part about it. So yeah, we're like trading it in. It's simple. It's like trading it in, right? Which is interesting because when we trade it in, we trade in instead of trading in the 10, we trade in the 5. So then once we know how to do the 5, we know how to do the 10. It's the same thing. Oh my God, that's so brilliant. That's so brilliant. So if we do 5 plus 5, I love the soundboards. Oh, thanks. Thanks. I like this one the most. There's that one. I like that one. Or this one. Can we do tens? Yeah, let's do some tens. So we understand how to make the fives, right? We understand how to make the fives. Now what we're going to do is we're going to make the tens. This is the way. Okay. I need to move my stuff. So, so this is what we were doing. And then we're going on to the next one. So that's what the next one is. That one is, oh, excuse me. That. All right. So we're here. We are making a 10. If we're making the 10, what are we going to do? I'm just trying to find my questions. All right. Here's my question. I did asteroid belts. So I was thinking it was to help the kids to understand. So when we do it, let's do 8 plus 8. Let me. Mark. Somebody called me a vampire too, or somebody called me a magician, and I was like, right, sorry. So thank you, Carter. But what we're going to do is we're going to use the abacus when we do it. So why are we going to do it? Because I need to show you that we don't have any more beads to add the 8. So if we don't have enough beads to add the 8, we know that we have this concept. This concept that we have is plus the 8 plus 2 equals plus 10. We need to. When we modify, we're isolating the 8. When we isolate the 8, it is equal to 10. Again, this is not balanced. We need to balance this equation. It's just like algebra. We need to balance the equation. So this is how the beginning parts of algebra. This is the gateway. Abacus is the gateway to complex math. So we have this concept. We're going to balance the equation. We have 8 is equal to plus the 10 minus the 2. When we look, we're going to plus the 10. This is what the 10 is, right? 10 is 0 and 1. Add the 10. And then what are we going to do? We're going to take away the 2. My final answer is what Carter mentioned. It is now 16. We can do it again with the 7. Again, we're not memorizing our doubles. We're memorizing the formula. So if I have 7 and my add-in is 8, what do? I need to plus the 10 minus the 2. So I'm going to plus the 10, take away the 2, and I can do it all day. Oh, that should be the next sound bit. I can do this all day, like Captain America. I can do this all day, right? So 4, if I do 4, and I want to add the 8, what do? Add the 8 is what? Plus the 10 minus the 2. I'm going to plus the 10 minus the 2. Let's do it again. Let's do it all day. 9. If I do 9, not enough beads to add the 9. What do? I need to plus the 10 minus the 2. Plus the 10 minus the 2. My final answer is 17. But see, thank you, Carter. Yes, plus the 10 minus the 2. Thank you, Carter. So if you notice, I'm not focusing on the result. I'm focusing on the add-in. It is the add-in that makes us figure out what numbers we're going to use. Does that make sense? So we could do it all day. Oh, so I don't know if I showed you this question. Do you guys remember this question? Right? This question. This is easy. This will be easy, right? 135 plus 200. Can I add 200? Yes, we can. So we can add 200. Now I need to add 4. Can I add the 4? No, I cannot add the 4. What do I do? How do I add the 4? How do I add the 4 here? How do I add the 4? Thank you, Nom Nom. How do I add the 4 here? Right? How do I add the 4? I need to find, how do I add the 4? I want to add the 4 here. How do I do it? Yes, nom nom. Yes. Plus the 5 minus the 1. And then, you're right, Char. You're right, Char. And then my next one is, can I add the 3? Notice it's scalable. Yes, I can add the 3. Exactly. Exactly. So what did we just do? I just showed you how the numbers can be scaled. You just need to know the basic, you need to know the fundamentals. Once you know the fundamentals, you can now add and subtract anything under the sun. I like that question, right? Because what did they do in school? They say, well, you got to round up and you got to round down and then you got to round all over the place. Hello, Blue Raptor. Welcome back. But we don't need a round, right? We just need to look at our abacus. It helps us to know every place value and what number we're going to add. Easy, right? I'm telling you. I'm telling you. Simple to use, easy to understand. But abacus makes it easy because you can see it. Do you have enough? Yes, you do. Then do it. This is actually fun. Preston, you're here voluntarily learning how to add and subtract on the abacus. That's the funny part, right? That's the funny part. The funny part is people are voluntarily coming into my room and to learn how to use the abacus. But thank you. I appreciate that. I'm very happy that you guys are okay with this, right? It's you know why? Because it's exciting to see when people start to make the connection. My parents are also in awe when I show them your life in my videos. Oh, thank you, Char. Oh my god. You're great. I'm always happy to be here. I remember the last time I was here, it was 120. Yeah. It kind of goes up and down. But as long as it's like as long as I have like people talking and stuff, I'm very excited to be able to have a conversation. And even for those that don't get it, you know what I mean? Because it gives me another way of explaining. There was this one person, and it was just kind of interesting how, they just didn't know how to do certain things. Carter, you're waiting. You're waiting for multiplication. Okay, okay. So this is what we're trying to do is understand that we can actually scale it. There's a lot of people will be like, this is like overkill. It's not overkill unless you understand the fundamentals, the basics. I tried to explain to someone, I've never used it for Cali education system. I tried what? I'm sorry. I tried explaining this to someone. I never used it before. Cali education system. I don't know what the Cali education system is. Sorry. I know Common Core. My kids did Common Core. It was fine. You know why? Because they knew abacus. I have 3 boys, and they all gone through the abacus curriculum. Oh, I see. Education system in California. Yeah, we are very big on Common Core, which is fine because an abacus, it's fine because you guys are solid in your adding and subtracting. Okay, are we done with the 5s? Are we okay with the 10s? I did Common Core and never did abacus. No, no. Abacus is considered an enrichment program. An enrichment. And I don't know why. I don't know why it's considered enrichment. I think everybody should use it. I think it should be part of the thing. Would have been nice to know abacus. You know what? And my kids take it for granted that they know the abacus. They don't understand like how beneficial it is. And cursive. Yeah, cursive is good too because it's a hand motion, right? It's different when you're punching in numbers. So yes. Um told the hubby in the private about the private lessons already. That's fantastic. Cursive's not hard. Cursive's just practice, just like the piano. Cursive is just like practicing the piano, just like writing whatever. Cursive is not hard. I remember when I was a kid, we did calligraphy. All right, so we're okay. We understand. We understand how to make a 10, just like the abacus. It is just like the abacus. It's all about practice. It's you get to the point where your mind is blown, right? You see how easy it is with the abacus. Math is not as difficult in the beginning as they say it is. There's a lot of terminologies in math that really kind of baffles me. Like they do a whole lot of number bonds and stuff. And I'm like, okay, that's fine. And they do a bunch of like manipulatives, and it kind of bothers me because we have all these manipulatives, but nobody goes to the abacus. I guess that's probably why I'm going to work well. I hope I can make it big. I hope I can make it big with abacus, but we'll see. All right. How are we doing? Do we want to do plus sevens or we want to do minus tens? It's the same thing. It's the same thing, minus the 10. They call it grouping and regrouping. Let me having a celebrity. Right? And you guys are in it for you guys are in it in the beginning. Oh, Ethan the most, because Ethan's been around for so long. Let's see. We can do grouping and regrouping. Here's regrouping. Let's see how we do on the regrouping. Num num num. Minus tens. Hey. Okay. Yep. Big boy. Okay. Big boy Bobby. Hey, do you ever remember there was I don't know if you're in California, but I remember in California there was a DJ called Big Boy. That's what it reminds me of. Big Boy. Okay. I should be sleeping. What time is it for you, Radha? I'm sure it's like super late. I'm in Cali. Oh yeah, Big Boy, right? He's not big anymore. I think he lost like a bunch of weight. 9 times. Oh, midnight. Yeah, I try to be here a little early. Big Boy in the morning. Yeah. Uh, pan tostado. We don't do single digits. We can do multiple digits. I'm going to put my bed. Do you? Yes, I do go live pretty often. I'm trying to be more regular. I'm going to be on 8 in the morning tomorrow. Tomorrow is Thursday. No, I'll be on again tomorrow night. For sure tomorrow night. And then I'll go again on the thing. Oh, good. That's a good one. I'm horrible at math. Oh, this is good. No. This is good. I like that one. That's a good one. So let's do, okay, wait. Oh, yeah. Let's do this. Thank you, Preston. Yeah, not a problem. Thank you for following. Okay, let's do this. Oh, wait. Let me copy down the number. Times up by 6, 7. Okay, before we do that, let's do this number. We're going to do subtraction. We want to do subtraction first. 7, 7, 8, minus 5, 8, 9. Let's do that first. Is that all right? Let's do that first. Okay, what are we doing? I can't see. There we go. There we go. There we go. All right. Okay, let's do this one first, and then we'll do the multiplication. So we do 7, 7, 8. And then we're going to minus the 5, and we're going to minus the 8. Can we minus the 8? No, we can't. What do we do to minus the 8? What do we do to minus the 8? We have to minus this 8. To minus the 8, we know minus 8 is equal to minus the 10 plus 2. So I'm going to minus the 10. Thank you, Char. Yes. I'm going to minus the 10 plus the 2. And then I'm going to minus the 9. What is minus the 9? Minus the 9 is what? Minus the 10 plus 1. Thank you, Char. Yes. Perfect. Right? So all we got to do is minus the 10 plus the 1. And what we just did, this is what we call regrouping. Period. Right? Makes sense? So what we just did is we just did regrouping. What we did is we memorized our formula. When we memorized our formula, right, we can use it anywhere in any world with adding and subtracting. It is now versatile. Oh, Pan. Okay. So let's do a little review. Thank you so much for letting me know, Pan. So when we look at it, we're going to do one. So this is when the beads touch when the beads touch the horizontal bar, this is one. We have two, we have three, and then four. After four, this is five. The top bead will always be five. So when I look, this is all five. Five, 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 five. Put the placement. Oh yeah. Oh, that's a good idea. So this is five. After five, we have six. So we can do all of sixes. These are all sixes. After six, we have sevens. These are all sevens. And then eight, this is all eight. And then nine, this is all nine. Pan, does that make sense? So what we're doing is we're looking how to read the abacus. It is so easy, easy to use, simple to use, easy to understand. Did that make sense? Pan, I don't know if you're still around. So when we look, the place value, every column is a place value. We have our ones, our tens, our hundreds, our thousands, I'm sorry, ones, tens, hundreds, thousands, and 10,000. So literally, it's so simple, it blew my mind. Right? Period. Don't feel dumb. That's not a good, no, don't feel dumb. Because what we're trying to do is we're trying to read the abacus. When we look, this is one. I don't know if period is still here. And when we're doing two. So then if you notice, we do two. That's two. Sometimes people need to see it. I don't know if period is still here. How do you do 10? Hold on. Hold on. Let me find my papers. Oh, good. Wait. Okay, wait. Okay, Pan, before we go. Before we do 10, this is 2. When the beads are touching this horizontal bar, does that make sense, period? Moses. This is, yes. Does that make sense? This is 2? Yes? That's 3. And then 4. That's it. 4. Right? So if I change it, let me give you another example, just in case. I don't know where you are in the world, right? I'm assuming, I don't know where you are in the world. I'm not going to assume anything. If I change this to pennies, right? Pennies, right, is 1 cent, 2 cent, 3 cent, 4 cent. These are cents. So I have 4. This is 4. What's going to happen for if I have 5? This is nickel. This is 1 nickel. This is 5 cents. Because this is 5 cents, that's what it looks like, right? Does that make sense? So we have 5. 5 is like that. 5. Oh, you can't see it. 5, right? Hello, Baka. Welcome. We have 6. I'm going to add a penny. That's 6. The blue is, yes, the blue is 1 nickel. Yes. And then we have 7. We have 8, right? We have 8. Sometimes people need to see the numbers. 8. And then 9. I don't know if period is still here. Thank you for the follow, Moses. Moses. Yeah, it is helpful for adults too. It's like brain gymnastics. And so it's like using, like going through Sudoku, jigsaw puzzles, word searches, and all that stuff, right? So it's kind of like a brain gymnastics. And what we're doing is we're doing arithmetic. I'm a visual learner as well. Yeah, it's great. I don't know if period's still around. Okay, so wait. Pan asked for 10. So 10, 10, this is 9. That's 10. That's all it is. 10. So when I look, 0, 1. Then we do 11. 11 looks like this. Then we do 12. 12 looks like that. That's it. That's it. If I do this, that's all five. Five, 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 five. So now we can count. Oh, let me do that again. So here's 12. We can do 22, 32, 42, 52. One green and no touching. So one green is one. Crazy learned, but I've always heard about the abacus. Yep. Hello. Hey, Copper. Welcome back. Right? So, yes, when we do one, that's just one. We do two, this is two. Because why? Every column is a place value. Every column is a place value. So it becomes very intrinsic to do place values, right? Good evening, Copper. Welcome. How do you do multiplication, though? Easy. Oh, Ben thought I was there. I'm sorry. I wish I could have. Oh, okay. So we're done with the grouping and regrouping. We understood that, right? That's what it is. Oh my God, I like this. I like this idea because of grouping and regrouping. This is one of the questions I had. Okay, multiplication. The first thing we're going to do in the abacus world is understand where our numbers are going to sit on the abacus. So to do that, we're going to do is we're going to understand, we're going to count our digits. 1, 2, 3, 4. It's a little bit different than new math, but not quite. It's a lot easier than new math. The difference between new math and abacus is that you write it out on a paper. Where in abacus, you don't need to write it out on paper. So we have four. We're going to count from my ones indicator, right? This is my ones indicator. I'm going to count from here. I'm going to count to four. 1, 2, 3, 4. So it lands me here on the thousands column. I promised myself to tape, but I didn't start yet. Ethan. So the first thing we're going to do is we're going to understand to do 6 times 2. That's easy. 6 times 2 is what? Like the abacus. Oh, I'm sorry. I like the abacus because it's not, that would be 12. Yes, thank you, because it's not about memorizing. It is not about memorizing. So we have 12. Thank you, everybody. So I'm going to put my 1, I'm going to put my 2. That's it. It's different than new math. What does new math have to do with anything? New math teaches us we do 20 times 60 is equal to 1,200. On the abacus, I don't need to worry about it. I already have it here. That's why we figured out our place value. Does that make sense? Are we all right with that? Can I make it easier for you? That's making it easy. So what's the next thing we're going to do? Right? The next thing we're going to do is 6 times 2, 6 times 4. That's it. This is what we're calling distributive property. We do this all the time. I don't know how to do times. I wasn't taught. No, no, no. You have to memorize the. Okay, yes. So 24. Yes. 6 times 4 is equal to 24. Copper, we'll have to wait on that one. So I'm going to add my 2. I add my 4. I add 2. I add 4. In mainstream math, we do, I don't know, 4 times 60 is equal to 240. Ugh. Okay, don't worry about it. Yeah. Hold on just a moment, Copper. Okay, what's next? We're done with our 6. What are we doing now? We got to do 7. 7 times 2. 7 times 2 is 14. What? Wait a minute. Wait a minute. We forgot to count. 1, 2, 3. So I got to count. 1, 2, 3. Whoa. So I have to do 14. I add 1. I add 4. I add 1. I add 4. I add 1. Right? There's not enough beads to add the 1. What do I do? Do we remember what do I do to add the 1? I need to add the 1. How do I add the 1 here? Do we remember? Can I add the 5? Yes. Yes, big boy. Yes. 1 is equal to plus the 5 minus the 4. Plus the 5 minus the 4. And then I go here. I need to plus the 4. Do you remember how to plus the 4? Plus the 4 is what? Plus the 4 is equal to plus the 5 minus 1. Plus the 5 minus the 1. And then what's next? 7 times 4. 7 times 4 is equal to what? 28? Yes, thank you, Char. 28. So we do 28 plus the 2 plus the 8 plus the 2. Can we add the 2? No, we can't add the 2. How do we add the 2? Plus the 2 is what? Plus the 2 is equal to plus the 10 minus 8. Plus the 10 minus the 8. And then this 8 needs to be added. So we go over here and we add the 8. So my final answer is what? 1608. That's my final answer to this question. 24 times that by 67. Yeah. But don't forget, we break it down. We know our multiplication fact. After you know your multiplication fact, then you do your adding and subtracting. But see, that's the difference between mainstream math. Mainstream math is a lot harder on paper when we can use the abacus to see where our numbers are, and I think that's the difference, right? Yeah, and I don't need to use like these blocks. I don't need to use these blocks where it'd be like I don't know what I'm doing with it. So, copper. Do you know your 2 times table? Oh, Rod, Rada, thank you so much for the goat. I hate the dim. Hi, E. Welcome back. Welcome back, E. Yeah, right. The math blocks, and then they have like these little pet like poppers, and then they have like what do you call it? Coins or whatever, flipping coins or whatever. And then they started using these counting bears, and I'm like, oh my god, oh my god. All right, where are you, copper? Okay, so that's multiplication. We're done. I've seen, what? I'm sorry. Now I've seen huge abbeys before. Does that, does that just add space like tens and thousands? I remember the counting bears. Nope, my teacher didn't teach me because it was hard for me, and so on and so on. The big one, like this, like if I had a bigger abacus, like 13 columns, or are you talking about like a big one, like a big one? This one's a teacher's one, so then they could see the back of the room. Because if you look, right, in comparison, yeah, yeah. This is a teacher's abacus because then they could see it across the room. That's it. And then it stands up, right? This one you can't stand up. All right. Okay, char. Uh Copper. I want the teacher abacus for decoration. Okay, copper. When we do multiplication, it is all it is fast adding, if that helps. Does that make sense? So when we do, we'll go slow, right? We'll do 5. We'll do 5. 5 is an easy one, right? We know 5 times 1 is equal to 5. How do I know? How do I know? Because it's just 1 5. Does that make sense? So if we do 5 times 2, 5 times 2, I have another 5. Do you see how I have 2 5s here? So what I'm going to do, I'm going to do the 5. I add the 5, and I need to add another 5. Do you remember how to add a 5? When we add a 5, what are we going to do? We need to plus the 10 minus the 5. Whoa. We're going to plus the 10 minus the 5. Thank you, big boy. Yeah. So when we do another 5, right? All we're doing is 5 times 3 is equal to 15. How do I know? Because I'm going to add another 5. Do I have enough beads to add a 5? Yes. I'm going to add a 5. So this is something you're going to have to remember, if that makes sense. When we look, we're going to add another 5, right? Times that by 4. 5, 10, 15. We add another 4, right? Can we add a 5 here? We got to do it again. Plus the 10 minus the 5. Plus the 10 minus the 5. Copper, I don't know if you're still around. So now I have 20. Maybe I'll do this as a post, but I don't know if that's gonna confuse people. So, but on the abacus, that's what we would do. I would tell my kids, this is how you do additive, what do you call it? Cumulative addition, right? So when we look at it, we need to understand that we're adding 5 plus 5 plus 5 plus 5. I've always wanted to learn the abacus. Oh, hey, Faith. So when we're reading the abacus, I'm still here. Just quit because I'm trying to focus. Okay. But does this make sense before I go on? I'll have to find a better way to explain that. I don't know. I don't really teach the kids. I don't really teach the kids multiplication. I just kind of assume that they memorized it. But I do have like an activity. Oh, maybe I should. Sorry, Faith. Let's do a review for Faith. So here we're gonna do 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, this is 4. The top bead will always be a value of 5. Then we have 6, 7, 8, and then 9. After 9, this is 10. How do I know that this is 10? Because every column is a place value. Start with a 5, and then you take away 5, and then you add the 5, and you take away again. Yeah. So going along with the pattern of 5, 0, 5, 0. Yeah. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. A little bit. The more I watch you teach, I'll eventually understand. Yeah. It's all about just looking and seeing the patterns. So it depends on what we're trying to do. So we have 55 and then 60. Yeah, right? 60. 65, 70, 70, 7, 5, 6, 7, 75, 80. Yeah, I see. Yeah, I see that. That's a good one, right? 80, 5, 6, 7, 8. And then 85 and then 90. Yeah, but it's the number pattern. It's the number pattern. Hey, 1, 2, 3, 4, 5. That's funny. My name is Lynette too. In the habit. Yeah, I just got that. Yeah, great. I'm so happy that you can. Okay. The reason why I was thinking. I love the soundboard. Okay, so here's another thing. I don't know if you want to take a look at this. It's a little much, right? But this is the 3 times table. So here's my 3 times table. I have 3 dinosaurs. The dinosaur is walking her brother, and don't forget the mother. There are 3 plates on each dinosaur, right? I haven't seen the abacus since grade school. So when we look, it's 3 times 3. 3 plates with 3 dinosaurs. So when we look, either we can count all of the plates or we can group them. So this is one way to look at the 3 times table. So we have 3 times 1 is 3, which is just 3 equals 3. 3 times 2 is 6, so it's 3 plus 3 is equal to 6. Or 3 times 3 is equal to 9, which means 3 plus 3 plus 3. And then there's many ways to look at it. If we do 3 times 1 is equal to 3, when we add a 3, it'll give me 6. It's the same thing as 2 times 3. If I add another 3, then I get 9. It's like the same thing as 3 times 3 is 9. So I have that one too, but I haven't built this book out yet. I'm still in the process because what I want to do is I want to add in division. So when I add in division, because multiplication is like because division is just multiplication with a missing factor. Yeah, so this is my other workbook that I'm in the process of making for only the 3 times table because I feel like that they're rushing the kids too much to learn the whole times table when they should just do it one number at a time. So that was my multiplication. All right, how are we doing? The threes, I see it as odds and evens, and then the next set is even and odds. Oh, that's interesting. Oh yeah, that's really interesting. And that's a good pattern. That's a very good pattern. Okay, that's my second yawn. It is time for me to head out. Okay. Thank you guys for joining. I'm so happy we were able to get to multiplication. Does anybody have any dying questions before I sign off? Anybody have any? I just got here. Ah, I know. I've been on since 8 and it's already 10, so I've been on for about 2 hours. So yeah, not a problem, nom nom. Not a problem. I'm gonna try to be more regular. And I'm not talking about my bowels. Yeah, not a problem, Faith. Not a problem. Thank you so much. Thank you for joining. Let me know if you let me. I hope to see you in my next live. Hey, Char. Yeah, you're welcome. I really appreciate it. Thank you, guys. Was yes, not so pro. You're here. It's yes. It's I'm late. I'm so sorry. Yes, I will see you guys later. I'm gonna try to be here 8 o'clock p.m. Pacific Standard Time. Tomorrow is Thursday. Yeah, Pacific Standard Time. Have a good night. I'm sure I'll be here for tomorrow. Yes, I will try to be more scheduled. Thank you guys. Thank you everybody for joining. I appreciate everybody here. Let me know if you have any comments, or let me know if you have any questions. I'll set up of some posts. I'm not sure if I want to do a post on this with the abacus. I'm not sure. I have to figure this one out a little bit more. Maybe, maybe I'll do this one. Maybe I'll do the other ones, but it depends. I'm trying to do a series of I don't know how to count. I got a lot of posts be like, I'm so confused. I'm like, what? This is I'm counting. I don't know what else to do. So I hope to see everybody again, and I will see you guys all in my next live. Bye, everybody. Oh, I'm 16 minutes away from my next reward. So I need to stick on for another 16 minutes. Am I going to stick around? Okay, you know what? I'll stick around for another 16 minutes. Should I do that? I don't know what this creator camp. Man, stop playing with me, bro. Give me something hard. All right, we'll do 16 more minutes. 16 more minutes. You guys are funny. Dog goo, do goo. I don't know what you're talking about. Thank you for the follow. What kind of hard question you want? I don't know what kind of hard question. I don't know. We could do this one. Oh, you know what? We'll do some subtraction. Let's do some subtraction. 231 minus 166. We'll do that. How about that? Can we do that? So we'll do 231 minus 100 minus 6. How do we minus the 6? Can we take away 6 here? No. Minus 6 is what? What is minus 6? Oh, excuse me. I'm powering it through. Minus 6. We know to minus the 4, right? Minus 4 minus 6 is equal to minus 10. Minus 6 is equal to minus the 10 plus 4. What did we just do? We isolated this variable. We want to minus the 6. Thank you, Char. Yes. So we're going to minus the 6. When we minus the 6, it is equal to minus the 10 plus 4. Minus the 10 plus the 4. Can we add the 4? Can we add the 4? Right? So now we're back to our formula, right? Can we add the 4? No. Can we add the 5? Yes, thank you, Char. Can we add the 5? Yes. So what we're doing here, this is associative property. That's what this is. Because what's going to happen is we will make parentheses plus 5 minus 1, right? We have minus the 10 plus is equal to minus 6. Associative property. That's what this is. Because we took this information and we're associating with that. So we're going to do plus the 5 minus the 1. And then we need to take away the 6 again. If we take away the 6, what do? Minus the 10 plus the 4. Minus the 10 plus the 4. We cannot plus the 4. How do we do it? We need to do plus the 5 minus the 1. Plus the 5 minus the 1. So my final answer is what? 65. 65. 65. Did that make sense? Thank you, Char. That one is a complicated one. Why was it complicated? Because it was a two-step. Associative property is what we needed to do. We had associative property. This associative property is associated with this 4. So what we did is in the abacus world, it's a two-step, right? And so this is the beginning parts of algebra. Algebra does 2 steps, and so this is associative property. Tricky 6. Yeah. So you'll notice that's what this is. These ones are the tricky ones. 6 has the most questions to be 2-step. 7 only has 3 questions. 8 has 2, and 9 only has 1. So we can do it. Let's do that. So let me show you. So when we do 13 minus 8, when we do 13 minus 8, we have 13 on the abacus. 13 on the abacus. When we minus the 8, we know how to minus the 8, right? How do you minus the 8? Minus the 8 is minus the 10 plus the 2. So I'm going to minus the 10 and I plus the 2. When I add the 2, there's not enough, right? So what did I just do? Minus the 10 plus the 2. How do we plus the 2? How do we add the 2? Minus the 10 plus the 5 minus the 3. So what are we going to do? Plus the 5 minus the 3. So my final answer is 5. Is that the quadratic formula? No, this is not the quadratic formula. This is just arithmetic. Does that make sense, Char? I don't know if anybody else is here. Because I did say goodbye to everybody. I said goodbye to everybody and they all probably left. So what we're doing here, right, is what we're calling a distributive, not distributive. Oh, no, you're still here. Good. Associative property. Associative property. I don't even know how to spell it. Associative property. Property. Yeah, I think this would be a better way. I think that's a better way. So we need to put parentheses around it. Thank you. Thank you. Associative. There we go. There we go. I should have changed the C to an S. I think that's what it is. I think this is what we call associative property. We take this information and we pop it into here. I think that's what it is. Because the reason why is because abacus world, we don't have math terminologies. So I think we're doing that. Yeah, I think so. Right? I think so. Because what can we do? I mean, it would be the same thing if I did. It would be the same thing if I did what? If I did, let's do another one. We can do another one. We'll do 14 minus, we'll do 14 minus 8 again. 14 minus 8. Minus the 8, I'm sorry, here it is, minus the 8. Minus the 8 is equal to minus the 10 plus 2. So what does that look like? I have 14 minus 8. Minus 8 is minus the 10 plus the 2. Minus the 10 plus the 2. So let's do that, right? Minus the 2. So if I rewrite it, minus the 2 plus 2 is equal to what? Plus the 5 minus 3. Plus the 5 minus the 3. I understand now the basics really matter in abacus. Yes, yes. See, once you get the basics, then everything is golden. What am I doing here? I had a thought. Oh, I got it. It was supposed to be, you could do it this way. 8 is equal to minus the 10 plus minus 3 plus 5. You could do that too. But you cannot do it here. I don't know. Associative property is kind of tricky because we don't use it in the associative property sense. In the abacus world, it's just like commutative property. So if you notice, abacus doesn't do it what it says. It says commutative property is the addition states. But in abacus world, this is not an addition state because we focus on the add-in, and I think that's the problem with this thing. How do you do 1 plus 1 on the abacus? We do 1. Can I add a 1? Can you add a 1? Yes. So I'm going to add a 1. That is what 1 plus 1 is on the abacus. Yep. Right, Copper? Yep. So when we look, we want to make sure we have enough beads. That's the reason why you do the things we do. Do you have enough? Yes. So I'm going to do it. Yep, that's it. Because if you look, that's why I have this framework. The framework is, do you have enough beads? If it is, then add it. If not, use the formula. Yeah, I was just thinking about it. Good, good. It makes sense, right? There's a framework when we do abacus. And this is the framework. Every number gets Every number has to go through this process. Every number. Either this number or this number. It doesn't matter. Every number has to go through the same process. Because if we did 10 minus 10 plus 2, 10 plus 2, can you do it? No. Then I got to use this, minus plus the 5. Plus the 5 is, plus 2 is equal to plus the 5 minus 3. Just stories. Hey, welcome back. What's the formula? Oh, this is the formula. Minus the 8 is equal to, because we're doing this problem, 14 take away 8. 14 take away 8. When we do 14, take away 8. Take away 8 is what? Minus the 10 plus the 2. Cannot plus the 2. So I have this 2, right? Do I have enough beads to add the 2? No. I got to go here. Because I don't have enough beads, what is it? Plus the 2? Plus the 2 is plus the 5 minus the 3. So I'm going to plus the 5 minus the 3. So my final answer is 6. Thank you, Dakota. Did that make sense, Copper? You all right, just stories? Did that make sense? So when we're looking at it, this is why understanding the basics, right? But then this is the framework. So the framework is, do you have enough? If not, then you use the formulas. If not, you use the formulas again. And this is the end. That's all it is. Oh, good, right? The more you do it, the more you'll see the patterns. The more you do it, the more you'll see the patterns. Thank you so much, everybody, for the hearts. Right? You want to do another one? We could do another one. We'll do 11. We could do 11. 11 minus 6. Can you show that 14 again? Yeah. 1, 4. I want to take away the 8. To take away the 8, this is my formula. Minus the 10 plus the 2. Minus the 10 plus the 2. Add the 2. Can I add the 2? Yes. Can I add the 2? No. I got to go down. Use the 5. Can I add the 2? Can I add the 5? Yes. So plus the 5 minus the 3. Plus the 5 minus the 3. Final answer is 6. So I rewrote it to include the associative property. I think I'm going to use that. Because you can do it this way, or you can do it this way. So we're going to 6, right? We do simple, right? If it's too complicated, we get bogged down. So I'm doing simple. 11, take away 6, minus the 6. What is minus the 6? Minus 6 is what? Minus 6 is what? Minus the 10 plus the 4. Minus the 10 plus 4. Thank you, Char. Yeah. Minus the 10 plus the 4. Uh-oh. Uh-oh. Can I add the 4? Is there enough beads to add the 4? No. What do I do? Can I use the 5? Yes. Plus the 5 minus the 1. Yes, thank you, Char. Plus the 5 minus the 1. Final answer is 5. So what do we do? Minus the 6 is equal to plus the 5 minus the 1. Yeah. So this is what we call a two-step. It uses associative property. I think I'm going to claim it. I think I'm going to claim the associative property. Maybe I should ask, where is, let's see. Chat. What is associative property? See, okay. I don't think I'm doing it right. Because associative property, it says here, associative property is when you do 2 plus 3 equals 2, 3 plus 4. Sorry, I'm looking at this thing. And so it's 5 plus 4 is equal to 2 plus 7 equals to 9. I don't know. You can change the grouping. So it's about grouping. I don't know. I don't know. I don't know. This is what they call associative property. They're grouping them. But what they're doing, what are they doing? I think it's because of this, right? It goes like that. And they do this. Maybe I could use it. What do you think? I don't know. I think I can use it because that's what they're doing. I don't know. We're kind of using it. I think it's kind of. I think it's kind of. Because they're doing it here, right? And we're doing it here. I don't know. I know I stretch it a little bit. Yeah, it's just a thought. Associative property. I think I'll use it. What do you think? Because the answer is still 9. I don't know. I think it's a little bit of a stretch, but it is still possible. Oh, I don't know. Because the definition is just different. The definitions in mainstream math is just different than the way we use abacus. And I think that's the problem. Right? Because nobody that does was it mainstream math has ever done abacus. Ha ha. Yeah. All right. How are we doing? Okay. I think we're done. How are we doing? Any last questions? Good. I think so. It's like a shorter version of associative. It's like a shorter version of associative property. I think so. I think so. It's not a. It's not. See, but that's the thing. It's not a. It's not a complete definition. Okay, great, Copper. I'm happy. See, that's what I'm saying. It's not a complete definition because I'm kind of modifying this one as well. Commutative property, right? Because it says addition states, but this is not an addition states. Yeah. I think so. I think I can utilize the associative property concept, but it won't be. I think so because that's what it is really. It's not that they're. I don't know. I don't know. I don't know. I have to think. I have to marinate on that one a little bit. All right. Okay. Okay. It's for real. I'm gonna go. Thank you guys for joining. Thank you so much for being patient with me, and I will guys see you guys all in my next live. Bye. Can we do one with Chinese? Do one what with Chinese? The question? So if I have 11, and I need to take away 6. I need to take away 6. How do I take away 6? Oh, I see. So you can trade this in and do that. And then you take away the 6. You do that. You could do that. Wow, that was kind of cool. Does that make sense? So we have 11. So let's trade this in to 10. This is 11. We take away 6. My final answer is 5. I did not need to do a formula. Yeah, that's what I'm saying. The Chinese abacus is cool, but it takes a little bit to understand. What about this one? 14. 14. Let's see, 14. Oh, sorry. 14. Take away 8. It'd be the same thing. I take this 10, take away 8. 5, 6, 7, 8. So my final answer is 6. I guess you don't need to do formulas. Yeah, because if we did 14, we showed you, right? 14. Trade this into this. Take away 8, take away 5, take away 6, take away 7, take away 8. So it'll be like that. So my final answer is 6. Yeah. Maybe the Chinese abacus would be for you. I don't teach Chinese abacus though. Just so you know. I teach Soroban. Those would have to be a different set of questions. So let's do this one. Let's do 700, 708. What are we doing? 700 minus 589. 778. Oh, we can't do it that way. We'll do it this way. 778. Take away 5. Take away 8. Take away 8. No. Take away 8. I can't see it. Because this is 6. This is 7. I can't trade it in. I think you still need to do one too many places on the ones. Oh. 5, 6, 7, 8. There you go. Thank you. 7. 5, 6, 7. But I need to take away the 8. How do I take away the 8? Minus 8 is equal to minus the 10 plus 2. Minus the 10 plus the 2. And then minus the 9. You still need a minus the 9 is equal to minus the 10 plus 1. Minus the 10 plus the 1. Yeah. You would still need the formulas. What? 5, 6, 7, 8. 5, 6, 7, 8, 9. Yeah, I think you still need the formulas. Yeah. Yeah. Yeah, I think you still need the formulas. I think so. Yeah, I think maybe as far as it goes is 6, that you don't need formulas, but I have to think about that some more. Okay, okay. I barely got that, but it's easier. Yeah. Well, yeah. So we have 7, 7, 8. Take away 5, take away 8. Take away 8 is minus the 10 plus the 2. Minus the 10 plus the 2. Minus the 9. Minus the 10 plus the 1. Yeah, I think it's the same. The Chinese one and the Japanese one is the same when it comes to this specific problem. All right. Okay. Now I'm going to go. I think I've got my creator camp or whatever it's called. All right. Thank you guys. I will see you guys in my next live. Bye, everybody. Have a good night, Copper. Thank you, Char. Thank you, Nom Nom. Have a good night. Oh my God.